Welcome to Chibuzor Math Physics. Today I'll be taking you through evaluation of limit. What is limit? In mathematics, a limit is the value that a function or a sequence, we call function a sequence, approaches. So a function approaches some value. So limit basically are essential to calculus and in finding continuity or defining continuity and derivative and even integrals. So today I will be dealing with some evaluation of the limit of a function and to show that its continuity or discontinuity. You'll be given a question and you are expected to show if the limit is continuous or discontinuous. So it is a bit tricky, but you just need to pay attention to the steps and you are good to go. So let us jump into it. Now we have this function here. The function is showing us that f of x is equals to this. This is f of x. There is f of x somewhere. So f of x is equals to negative x negative 1 if x is less than negative 1. This is a sign of less than. In mathematics, we don't need to write less. So this is mathematical way of representing less than. So if x is less than negative 1, at 0 if x is equals to negative 1, and 1 over x if negative 1 is less than x and it is also less than 0. Ln of x if x is greater than 0. So let us see what we are expected to do. We are expected to evaluate limit of f of x and the limit of f of x when the limit approaches negative 1 from the negative side, and also as the limit of f of x approaches negative 1 from the positive. So there are two things here. You must evaluate the limit when it approaches negative 1 from the right hand side and when it approaches negative 1 from the left hand side. And these two things must be equal. Because if they are not equal, then the limit does not exist. Another thing, you are asked to show if the limit exists. So does limit as x approaches negative 1 of this function f of x exist or not? So we are going to see if the limit exists or they don't exist. Another thing is if f continues or discontinuous at x is equals to negative 1, then if it is discontinuous, you need to classify the discontinuity as a removable jump or infinite. So we have some certain work to do here. If the limit is discontinuous, then you need to classify its discontinuity as infinite. So I will show you how to do that. So let us jump into it. Number one, we are proving that limit of f of x, the function here, f of x is the function which represent the limit of some variable x which approaches negative 1 from the negative side. And since it is from the negative side, if we go back to the function we were given, we see here that from the negative, it is if x is less than negative 1. This shows that this is negative. So negative x minus 1 is our negative. So we will be using this to solve, to look for our limit as x approaches negative 1 from the negative. So we just need to take negative x negative 2, put it into our function. Remember, this f of x negative 2 negative x negative 2 represent the function f of x. So when we put it, we will have, because of these two negative sign, we have negative negative 1, which becomes positive 1 minus 2, and negative negative will be positive. So that's why we have 1 minus 2, which gives us negative 1. So in the negative side, the limit as x turns to -1 will give us -1. So this is what we got as we try to find the answer as x approaches -1 from the left. So now let us find the limit as x approaches -1 from the right. At any point in time, you can pause the video, try to solve it, because mathematics deals with solvings, a lot of solvings. You have to practice and practice and practice. You don't need to keep watching. Sometimes pause the video and try doing it yourself. So let us proceed as we go to find the limit of x from the positive. So from the positive side, we will have 1 over x. Why? Because that is what the function says. If we look at this function, we see that -1 is less than x and is less than 0. So it means that 1 over x is the right hand side, because you can see that it's not even negative before 1 divided by x. So we use this value here to find the limit as x turns to -1 from the right hand side, which is from the positive. And when we do that, we just need to replace -1 in x, so that we have 1 divided by -1, which gives us -1. Now, guess what? What do you think? We have proven that the limit as x turns to -1 from the left hand side is equal to the limit as x turns to -1 from the right hand side. So if they are equal, what happens? It means that the one side limit are equal. That is, the limit exists. Why? Because limit as x turns to -1 from the negative f of x is equal to the limit as x turns to -1 from the right, which is positive, of this function f of x, and two of them gave us -1. Then f of x, we will conclude that it is continuous at x equals to -1. Therefore, limit as x turns to -1 of the function f of x exists. And we can put our conclusion this way. And we have succeeded by showing that our limit exists and they are continuous. You can pause the video, try resolving it yourself so that you get the concept. Let us proceed, because there is part B. We are to also evaluate the limit as x turns to 0 from the negative of this function f of x, and the limit as x turns to 0 from the positive of this function f of x, So you are also to show if the limit exists. So does the limit as x turns to 0 of that function f of x exist? Is f continuous or discontinuous at x equals to 0? If it is discontinuous, then you have to classify the discontinuity as a removable jump or infinite. You can pause the video and try solving it yourself. Just like the way we did in the first one, we tried to show that the limit as x turns to -1 from the left, which gives us -1, is equal to the limit as the x turns to -1 from the right, which also gives us -1. So therefore, we concluded that that limit exists. So here you are also to show that the limit as x turns to 0 from the left is equal to the limit as x turns to 0 from the right. If the limit as x turns to 0 from the left is not equal to the limit as x turns to 0 from the right, so therefore the limit will not exist, because for that limit to exist, the left hand side and the right hand side must be equal. By now, I know you might have solved if you pause this video and you have tried it. So let me show you what to do. Now, we have seen from the function, the same function that we were given in the beginning, we will use the same function to find our limit. So from the left and from the right, you will pick your value here, because this represents our function f of x. So we are going to use 1 divided by x. So we use 1 divided by x from the left-hand side. We first of all prove that this limit as x turned to 0 from the left exists or not. So what are we going to do? It turned to 0 and we have the function 1 divided by x. If you substitute 0 in x, you will have 1 over 0. In mathematics, there is nothing like 1 over 0. When you have anything like 1 over 0, it is undefined. It is undefined. Even if you put in your calculator, it will be math error. So this is undefined. But anything that is divided by 0, it means it is a very big number. 0, it is very big. So it is negative infinity. It is negative infinity because we cannot divide this by 0. It is negative infinity. Therefore, we can say that the function decrease without bound. They decrease without bound. They continue. They continue going. Because infinity is something you cannot reach. Maybe in the other world, but in this world, it is something that continues. Have anybody asked you to go to infinity and you went there? No, you can never reach infinity. So it decreases without bound, and it will continue to decrease, and you will never get there because it is infinity. So we say that this undefined 1 divided by 0 will give us negative infinity. So let us find the limit as x turns to 0 from the right. When x turns to 0 from the right, according to the function we were given originally, we will use ln of x. If you are new to this channel, you can watch the previous video where I find the derivative of ln of x and also the integral of ln of x. If you integrate ln of x, you will find out that you will still get 1 over x. So it means that this ln of x here, if you try to find what is ln of x, it is also 1 divided by x, which will also give us negative infinity. Or if you substitute, direct substitution, you put 0 in this x, ln of 0 is negative infinity. It also means that the function decreased without bound. What are we going to conclude? One side limit are equal because we have the limit from the right hand side to be negative infinity, and we have the limit from the left hand side to be negative infinity. Therefore, it is continuous at 0. X, the limit, the function f of x is continuous at x equals to 0. So we will say that our limit as x turns to 0 of this function f of x exists. Why? Because the limit of the function x turned to 0 is from the right is equal from the left. Why? Because both of them are negative infinity. And that is the end of this video. I hope you like what you see. Watch the previous video where I do introduction on how to deal with limit before you get to this type of cases where you need to find a limit and determine whether the limit exists or they are continuous and discontinuous. And if they are discontinuous, you might be expected to show the removable jump, or what we call the infinite. Otherwise, God bless you as you watch this video. Don't forget, subscribe. My name remains Augustine Galagash.